Hi, my name is Rhys Oxenham. I manage the field product management team here at Red Hat. We're responsible for BU-led strategic customer engagement and also technical enablement of our field associates. Over the next few minutes, I'm going to be providing a live demonstration of the latest capabilities and features of the OpenShift Assisted Installer, a web-based utility that helps with the deployment of OpenShift, simplifying the provisioning of an OpenShift cluster right from the ground up. Over the past few months, we've seen some incredible leaps forward from the engineering and product management teams behind this technology, and I was excited to be asked to follow up my previous video. The tool that you're about to see is primarily targeted at bare metal clusters, and I thought it best to use real metal systems this time around. I'm going to be deploying a 3-node cluster, where all nodes are simultaneously master and worker nodes, demonstrating a use case that is in significant demand from our customers and partners, especially for edge scenarios, and where bare metal affords customers the ability to also run virtualized workloads, or workloads that can exploit hardware functionality such as GPU acceleration. The latest version of the OpenShift Assisted Installer is tightly integrated into the cloud.redhat.com portal, and the version you're seeing right now is part of the staging environment, so it's not yet what our customers are able to use, but will closely mimic how we expect our customers to use it. From within the cloud.redhat.com portal, we have the ability to view all of the currently deployed clusters, as well as create new ones, and be guided through the process. Here you can see that I do not have any defined already, so we'll need to follow the wizard to help define a new one. The first question is whether I want to deploy an OpenShift dedicated cluster, or one that I manage myself. In this staging environment, the only option available to me is the normal Manage My Own option. Then it'll ask me where I want to deploy this cluster, whether I want it to be on the public cloud somewhere, or somewhere within my data center, or even running right here on my laptop. The Assisted Installer, as I explained previously, is targeted at bare metal clusters and is the entry point for the workflow we're going to be demonstrating today, even if the intention is to deploy on non-bare metal environments like virtual machines. So we'll select bare metal here. Now it's going to ask whether we want to deploy using the standard user provision infrastructure or with the Assisted Installer route. And for this, we'll of course select the Assisted option. Here's where we start to see some familiar asks. We first have to give the cluster a name, and this name is important as it will be appended to the DNS domain to form the full name of the cluster. As I'm deploying into an existing bare metal environment, I'm going to call my cluster PEMLab. Next it asks which version of OpenShift I want to deploy, and the only option here is 4.6 currently, so I'll leave it as it is. And finally it provides an option for me to input my pull secret. So the installer has the correct authentication and authorization credentials to pull the container images required for both installing and operating the OpenShift cluster. Now one of the great additions, now that this is integrated within cloud.redhat.com, is that we not only get single sign-on support, but it can also automatically grab my pull secret that is associated with my Red Hat account. Hence why this has already been pre-populated for me. Now I'm ready to select Save and Continue. The next page is where the bulk of the configuration will take place. The cluster name has been carried forward from the previous section, and like before it will give me the option to download the Discovery ISO, and when hosts are provisioned with this ISO, they'll automatically appear in this pane ready for us to utilize as part of the new cluster. Let's download this Discovery ISO now. The clever part of this is that the Assisted Installer will dynamically create a new Discovery ISO for us, a CoreOS boot image containing all of the necessary credentials and API endpoint information for the nodes to be consumable by this new cluster in a zero-touch fashion. Simply boot the ISO, and all of the rest is completed from within the Assisted Installer window pane. For troubleshooting, it asks us to pull in an SSH public key, so that in the event of the nodes not appearing as expected, we can at least connect into the machines and do some troubleshooting of the agent service that gets spawned automatically. I thankfully have this handy. This section also confirms whether we want to use an HTTP proxy, and if so, we can ensure that that gets configured within the ISO. But in our case, we don't need one. Behind the scenes, the Assisted Installer platform will now generate our custom ISO and make it available on an S3 bucket for our download. This takes about 20 seconds or so I'll speed it up a little. Now we have the endpoint of the custom ISO. We have about an hour before the object gets deleted, which will be plenty of time for us. Let's copy that URL for now and move over to our bare metal environment. For access to the cluster, I'm using a jump host that I'm accessing over VNC. primarily because I'm going to need to attach this Discovery ISO to my bare metal hosts over a virtual media interface. And given that these systems are based in the US, it's generally not a good idea to have them pulling the contents of the ISO over the Atlantic, and hence why I'll attach them directly from a VM residing in the same data center. A brief overview of the setup that I'm using here. I've got 3 Dell FC430 blades, and I've opened up a virtual console to each of them that will allow us to monitor the progress, but also attach the Discovery ISO directly. We're also using 3 bare metal machines here to demonstrate the converged master and worker configuration, but it would be absolutely possible to have additional nodes, or even virtualize the master nodes and have only physical bare metal workers. Given that the assisted installer follows the bare metal IPI approach of deployment, we have a few key requirements to bear in mind. You'll need to ensure that you have at least 3 master nodes. That's standard across OpenShift. You need to make sure that those 3 masters have layer 2 network adjacency between those nodes, that you have an IP address allocated each node via DHCP, and that the network that gets attached has routed access to the assisted installation API. You also need to make sure that there's basic DNS resolution to allow the nodes to pull container images from the default sources. Once the cluster is up and running, it self-manages 2 additional virtual IPs for both the API and ingress. It also takes care of load balancing across the master nodes and manages internal cluster DNS. Therefore, there are very minimal external requirements to get this environment up and running. So let's first get the ISO downloaded into this environment, recalling that we've already got the location of the ISO ready to be pasted in. Now that I have that locally, I can attach it to each of my bare metal machines through the virtual media interface. Let's first take node 10. Select the Discovery ISO that I just downloaded and map it to my node. I then need to force the next boot device to be the virtual CD-ROM. And then I can power the machine on. We can watch this machine turn on through the console. Now we'll repeat that process for node 11 and node 12, my second and third masters. I've now got all 3 of my masters powering on and be instructed to boot from the attached Discovery ISO via the virtual CD-ROM interface. Given that they're bare metal machines, they will take a minute or 2 before they attempt to boot the ISO. My node 11 seems to have made it through the BIOS process faster than the other 2, so we'll see this one run the ISO first. You can see that it immediately starts to pull the kernel, and in a few seconds you'll see it pull down the RAM disk, and finally the ignition config that got generated dynamically for us. Again, this process will take a considerable amount of time due to them all being pulled over the network, so I'll speed this up a little for convenience. So that's the first node, node 11, that has finished booting up, and we should expect to see this report into the assisted installer UI momentarily. And there it is, currently in a discovery phase, where the agent running on the machine will report information about the system, such as CPU count, memory, disk availability, and much more, which we will show shortly. Let's give it a few more minutes for all 3 to report in. If we dive into one of the nodes, you'll see that it's correctly been identified as a Dell FC430. It correctly shows the 400GB solid-state drive, the networking interfaces, and the IP address assigned via DHCP. The status of all of these machines is now pending input, as we have to provide further configuration before the machines will be ready for cluster deployment. One of the new changes is now the automatic role assignment, where there's logic built into the platform to help with best fit role placement based on available nodes and their respective configuration. Here we're going to leave it all on automatic, as we only have 3 nodes and hence they'll default to both the master and worker configuration, but there are options for manually overriding should you wish. There's also some additional options for each of the hosts on the right hand side of the pane, and as an example here you can override the host name. Now this is important because in my environment my DHCP server assigns the hostname to the node, hence why it's showing correctly here. But this may not always be the case for all scenarios, and if you're using an environment without hostname allocation via DHCP, these nodes would simply show up with a UUID as a placeholder, and you need to use this option to make the changes. I'll leave this as it is because it's already correct. It's also possible through this menu to disable a node, view host events, or indeed delete it entirely from the discovered hosts list. Let's move on with the configuration of our cluster. One of the new integrations is the ability to use a temporary 60-day domain, which can be incredibly convenient if you're deploying into an environment that only has very basic DNS, or a DNS infrastructure where you can't make new entries, or if you don't want to manually update your etc host file to reference your new deployment. Here we can ask the assisted installer to dynamically create an entry for us in Route 53. However, in my environment I'm happy to use an etc hosts override, so I'll leave this unselected for now. Next I've got to enter the base domain of my cluster, and as this is a real environment I'm going to match the base domain with the host names of my machines, and combined with a cluster name this will form the full domain of my new cluster, pemlab.rdu2.redhat.com. As before, we have two options for setting up networking, one in which there's basic default networking or a more advanced configuration where you can override the default subnet allocations, but I'll stick here with the basic options. There's only one network subnet between machines that's been discovered, and that's what's showing here. My bare metal machines have multiple interfaces but only one with DHCP, and I'll use that base network for the whole cluster. Like earlier iterations of the assisted installer, we have to define virtual IP addresses for both the API endpoint of the OpenShift cluster and also one that's used for ingress routing to applications residing on the cluster, including the OpenShift console. Here I could enter them if I had already reserved IP addresses or pre-populated my DNS infrastructure with these endpoints, but a great new feature is that I have the ability to automatically allocate virtual IPs from the DHCP service if permitted to do so. This feature will retain a lease on two addresses and use them as the virtual IPs that are managed by the cluster itself with KeepAliveD. My DHCP server in my environment will happily allocate IP addresses to any device on the network, so I'll use this approach now, remembering that if a customer chooses this approach, they'll either need to manually update their DNS records or use the etc hosts override approach that I'm going to be using shortly. I'll select Validate and Save Changes at this point and check that it's able to get a lease or two for these endpoints. There we go, .177 for the API and .182 for the ingress traffic. Finally, it'll ask whether I want to change my SSH key from the one it previously used for discovery, which I do not. Now I'm ready to install a cluster, as confirmed by the now blue Install Cluster button at the bottom. You'll also briefly see that the node status has changed to Known if I scroll up a little. Let's go ahead and kick off the installation. Here you can see it takes us to the next pane where we can see that it's preparing for installation. One of the new changes that you may notice is that in the bottom left-hand corner, the Abort Installation option is available, allowing users to recover and retry installations, which can be incredibly handy if there are any issues during installation, especially when you're running some slow-to-boot bare metal servers. There's also a new cluster events pop-up which will give you real-time deep dive insights into what's happening underneath the covers, and we'll return to this a few times over the course of the deployment to see the type of content that gets pushed here. As you can see, the nodes have now progressed into a starting installation phase, and you'll also witness that one of the nodes has been selected as the Bootstrap node. Like before, we're able to deploy a cluster without a dedicated Bootstrap node, ensuring that the deployment footprint is minimized. The deployment process simply deploys a temporary two-node cluster on the other two nodes, where the third stand-in Bootstrap machine runs the OpenShift installer. Then when the cluster is up, it pivots and gets deployed as a third cluster node, restoring full high availability and quorum to the cluster. First up, you'll see that it appears that nothing is happening on the machine's consoles, but via the UI you'll see that the machines are changing state and that the progress has stepped forward. At this stage, the two normal masters will be provisioned with the CoreOS image onto the root disk of the node. And if we watch the console output, now that I've sped it up a little, you'll see that the two machines, node 12 and node 10, reboot and start up from the hard disk, no longer relying on the Discovery ISO, even though I've not disconnected it yet. Node 11 will continue to orchestrate the deployment as the temporary Bootstrap machine, and will only reboot once the cluster is up and running. Here we can look at the individual node statuses. Node 10 is reporting as rebooting, as it was the second node to reboot onto its root disk. Node 11, the bootstrap node, is waiting for the control plane, or in other words, waiting for the other two nodes to form the two-node cluster. And node 12 is in the configuring stage, where it's actively bringing up the OpenShift control plane pods and helping to bring up the cluster. Throughout all of this, the cluster events pane can give a much more in-depth view of what's going on, and can be filtered if required, which is very useful for troubleshooting. Here you can see the disk write processes and the state changes. The two masters will reboot a number of times as they establish the two-node cluster, involving the deployment of container images and starting of essential cluster services. I sped up the video considerably here, but you'll see that Node 10 and Node 12 have completed their reboots and are now operational. If we switch back to the assisted installer window, we should see the status of these nodes update. One of the nodes will first go into a joined phase, Node 12, and then the second master, Node 10, will follow. At that point, the two-node cluster has been fully established. Now we simply need to wait for the OpenShift installer, still running on Node 11, our bootstrap node, to finish its operation, so the node can be rebooted and turned into our third master. You'll see the UI update the status to rebooting, and if we watch the system's console, we'll witness the CoreOS image being written to the root disk and for the system to reboot, no longer relying on the Discovery ISO and no longer taking the role of the bootstrap machine. At this point, the deployment of the third master is handled by the OpenShift cluster itself, and all of the required services will be automatically deployed. Like before, if we look at the console log, you'll see the detailed list of steps that the provisioning process has taken. You can also download the installation logs for all of the machines, which can of course be incredibly useful for troubleshooting or simply gathering detailed information about how the cluster was deployed. Simply select the link at the bottom and your browser will download a tarball where each node will have its own full set of logs and various other elements that may be useful. Here we are at 95% and almost deployed. Let's give it a little while to finish up. Our third master node should be rebooting for a final time right about now before the installation will be finalizing. And there we go, installation has been completed. Now, like previously, we're immediately provided with a console URL for us to connect to. We're also provided the username and password that we'll need to authenticate against the cluster. We're also able to download the kubeconfig should we want to use the CLI tools against the cluster. However, as we previously discussed, we're going to need to modify our etc host file as we selected dynamically allocated virtual IPs and certainly didn't update any of the environment's DNS. So we need to select the option where it says not able to access the web console, and it will give us a well-formatted list of entries that we can simply copy into our etc host file as a workaround. I'll paste those into my local etc host file on my workstation. Now when I select the Launch OpenShift Console button, I should be presented with the OpenShift Web Console. I'm going to need to force my browser to accept the self-signed certificates, but I should eventually get through to the login page, confirming that my cluster is operational. The username is the standard kubeadmin, and I can copy the password directly from the assisted installer page. As you can see, the cluster is still coming up and starting all of the required pods. So in the meantime, let's jump over to the CLI and ensure that the kubeconfig is working properly. I use the file we just downloaded and ask the cluster for a list of nodes. Here clearly showing that we have 3 nodes, each of which have both got the master and worker roles. We can also verify the version, here being a 4.6 nightly or pre-release version. We can also dig around in the UI confirming the same, and also demonstrate that these nodes have corresponding bare metal node objects, albeit ones that will need to be updated with the proper out-of-band management credentials if we want the metal cubed components to manage them. Although it's important to note that Metal Cubed is currently disabled with assisted installations on 4.6, primarily because of the requirement for a separate provisioning network. It's intended that Metal Cubed integration will be reactivated in 4.7 when a separate provisioning network is no longer required, and where we'll be able to leverage some of the granular services that Metal Cubed may be able to provide to us. From here we can go ahead and deploy any other operator. As an example, we can deploy OpenShift Virtualization or CNV, especially as this is a real bare metal cluster. But at this stage, it's just like any other OpenShift cluster. We can deploy and manage any type of application on top of it. I won't go into this in too much depth and we'll speed up this section a little, but the installation is really quick and easy, and you can see that the UI dynamically expands to show a new entry for virtualization under the workloads section. And there we have it. That concludes the demonstration. I hope it was useful and clearly demonstrated the excellent new assisted installer options. I'm sure the engineering and product management teams would love your feedback, so please don't hesitate to get in touch with myself or any team members if I can be of any use. Thank you for watching.